Formation of complex ion. This is today's lesson. Let us see a compound with complex ion. Potassium, hexacyanoferrate 2. This is potassium salt of complex ion. Let us write the name of the compound. Potassium hexacyanoferrate 2, which is commonly known as potassium ferrocyanide. IUPAC name is potassium hexacyanoferrate 2. Why 2? Let us see the matter. Here, suppose oxidation number of iron is X plus oxidation number of potassium is 1 plus 1 into 4 plus oxidation number of cyanide ion is minus 1 into 6 is equal to 0. Here X is equal to minus 6 will be plus 6. Here plus 4 will be minus 4, that is plus 2. So oxidation number of iron is plus 2. That is why this is potassium hexacyanoferrate 2, potassium salt of complex ion. Let us see complex ion here. Hexacyanoferrate 2, its charge is 4 minus. Potassium plus 4, this ion 4 minus. This is complex ion. In this lesson we are going to learn formation of this ion, formation of hexacyanoferrate 2 ion. So let's go to the detail. In the salt of potassium, the complex ion is this. Hexacyanoferrate 2 ion. Let us see electronic configuration of iron. Atomic number of iron is 26. Electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6. Here 18 electrons. Now 3d6, 4s2, then 4p0, 4d0 as well, because there are these subshells, but p and d subshells contain no electrons. That is why 4p0 and 4d0. In this ion, oxidation number of iron is plus 2. That means iron donated 2 electrons. Then electronic configuration will be 3d6, 4s0. That is, these 2 electrons have been removed. So 3d6, 4s0. After that 4p0, here 4d0. Now let us see electronic configuration of iron 2 plus ion in box method, 3d orbitals, 1 2 3 4 5, 4s, 4p, 1 2 3. After that, 4d orbitals, 1 2 3 4 5. 3d orbitals contain 6 electrons. Let us distribute these electrons according to Hund's rule. 1 2 3 4 5. Here 6. These are 3d orbitals, 4s orbital, 4p orbital, 4d orbitals. Let us write another step. Ion 2 plus ion. Here 3d orbitals, 1 2 3 4 5. First orbital contains one pair of electrons. To get stability, this is number 1, and number 2 is when ligands come closer to ion 2 plus ion, then here another thing happens, that is these unpaired electrons get paired in this way. This single electron shifts here to be paired. This single electron shifts here to be paired. Then these two orbitals become vacant. It happens due to get stability and because of the presence of ligands. Because of the presence of ligands and to be stable, these 4 unpaired electrons become paired and 2d orbitals get vacant. Here 4s, these are 3d orbitals. Then 4p and 4d, 1 2 3 4 5, 4d orbitals. By experiment we know that this ion is diamagnetic in nature. That means this ion has no unpaired electrons. Here we see that ion 2 plus ion has no unpaired electrons. That is why this is diamagnetic in nature. Number 2, this ion, this complex ion is octahedral in shape. If it is octahedral in shape, then what is its hybridization? Let us look at the matter. Here hybridization is these two 3d orbitals, one 4s orbital and these 3 4p orbitals. That is, hybridization is d2sp3. Hybridization that occurs in ion 2 plus ion is d2sp3. Total 6 orbitals. So here ion 2 plus ion, then 6 orbitals, 1 2 3 4. These 4 orbitals lie in a plane and another 2 orbitals, one orbital above the plane and another orbital below the plane. These are the 6 hybrid orbitals, d2sp3 hybrid orbitals. With these 6 hybrid orbitals, 6 cyanide ions. This is cyanide ion carbon contains one pair of electrons. With this one pair of electrons, cyanide ion forms coordinate covalent bond with the vacant hybrid orbital of ion 2 plus ion. Similarly, cyanide ion forms coordinate covalent bond In this way, hexacyanoferrate 2 ion is formed, in which 6 cyanide ions form 6 covalent bonds to ion 2 plus ion, which is octahedral in shape. This can be showed simply in this way: ion 2 plus ion, cyanide ion, another cyanide ion, cyanide ion, cyanide ion. Above the plane, one cyanide ion, and below the plane, another cyanide ion. Cyanide ion contains one pair of electrons, that is in this way: carbon, triple bond, one electron of carbon, another electron from potassium. That is why it is negative in charge with one pair of electrons. This is negative ligand, which forms coordinate covalent bond to the ion 2 plus ion with vacant hybrid orbitals. In this way, hexacyanoferrate 2 ion complex ion is formed. Complex ion hexacyanoferrate 2 ion, which is diamagnetic in nature because it has no unpaired electrons. This is octahedral in shape because here D2sp3 hybridization occurs. 6 orbitals participate in hybridization, and after hybridization 6 hybrid orbitals are formed. In this complex ion, oxidation number of ion is +2. That is why this is a hexacyanoferrate 2 ion. Cyanide ion with negative charge. Suppose this is formed after ionization of potassium cyanide. It is ionized to potassium ion and cyanide ion. Now let us see structure formula of cyanide ion. Out of 4 electrons, carbon used its 3 electrons to form 3 bonds with nitrogen. Another electron is left. This species took another electron from potassium plus now. For this electron, this is negative in charge, and now it contains one pair of electrons, by which it forms coordinate covalent bond with vacant orbital. This is about cyanide ion, negative ligand. Definition of ligand is the negative ion or neutral molecule like ammonia, water, that contain lone pair of electrons, by which this can form coordinate covalent bond with vacant orbitals of transition metal atom or transition metal ion. These negative ions or neutral molecules are called ligands. This is all about formation of complex ion, hexacyanoferrate 2 ion. Number today. Thank you very much.